For today's video, we're going to do something a little different. I'm going to show you in a very generic way how to convert from standard form of a linear equation to slope-intercept form of a linear equation, and then also from slope-intercept form of a linear equation to point-slope form. Okay? This may not be applicable to everybody. It might be kind of advanced, it might not be kind of advanced. It depends on where you're at. But hopefully some of you might find it useful. So I'm going to start with doing a general conversion from standard form to slope-intercept form. Okay. And so to show this to you in a general way, we know that standard form is ax plus by is equal to c. Okay? And I need to get it into slope-intercept form. And that's where my y is on the left-hand side and everything else is on the right-hand side. So in order to do that, I'm going to subtract by this ax term to both sides. Okay? And so that means on the left-hand side now, I'm just going to have by. And then I'm going to put this in a specific way. I'm going to put negative ax first. And then I'm going to have plus c on the other side. Sorry, on the end. Okay. Now to get y alone, all I'm going to do is just divide by b. So I'm going to divide by b to both sides, which means I need to divide both of these terms by b. You could also just multiply by 1 over b and you get the same result. So on the left-hand side, I'm going to get y. And then on the right-hand side, I'm going to get negative a over b x plus c over b. Okay? And that is actually the answer I'm looking for. If we look at slope-intercept form and I write out its general idea, we have y is equal to mx plus b. In this case, we use a lowercase b. Note that m in this case is just negative a over b, and the lowercase b is just capital C divided by capital B. And so from here, we've converted from standard form to slope-intercept form. Now to continue this, we're going to look at changing from slope-intercept form to point-slope form. Now, in all honesty, I could continue from where I'm at with y is equal to negative a over bx plus c over b, but then it gets very confusing. So instead, I'm just going to use y is equal to mx plus b and convert that to point-slope form. But, you know, if you really want to know what y equals negative a over bx plus c over b looks like in point-slope form, you can just use the conversion that m is equal to negative a over b and little b is equal to capital C divided by capital B and do it on your own. But for now, I am going to add a couple more pages because I forgot to do that. I am going to take y is equal to mx plus b and convert it to point-slope form. Okay, we're going to go from slope-intercept form to point-slope form. All right, so starting off, we have y is now going to be equal to mx plus b. And then from here, I need to get m and x alone. So that means I need to subtract B across. And then we're going to do a little bit of manipulation of what our terms are. We're going to come to an understanding of what we have. So on the left-hand side, I'm going to get, I should actually do this in orange, I'm going to get y minus b is now equal to mx. Okay. Now, I'm going to do something that's going to look a little weird, but I think it'll make sense once I move to the next step. I'm actually going to take x, and I'm actually going to subtract it by 0. So I'm going to say that x is going to become x minus 0. Since I'm subtracting 0, I'm not changing anything, but I'm just saying that x is going to be replaced by x minus 0. And we're going to get this form here, this equation here. We're going to get m times the group of x minus 0. And the reason for that is if we look at point slope form, and I'm just going to write out what point slope form looks like. It's y minus y1 is equal to m times the group of x minus x1. And here's where we're going to come to our understanding. y1 in this case is just b, and x1 is just 0, which makes perfect sense because b, if we remember, is the y-intercept of our line. So in this case, we have x1 comma y1 is just equal to 0 comma b. And so in this case, this is the conversion that we use to go from slope-intercept form to point slope form. And that'll do it for today's video. I don't know if this helped you guys at all, but it's just something I wanted to bring across because a lot of times, or sometimes your teachers or maybe your textbooks might use a general conversion problem like this to try and throw you for a loop. So I just wanted to cover it. Hope it helps.